All right, guys, Mr. Antonucci here. In this video, we're going to cover two topics. One is working with the mean value for theorem for integrals, and the other is we're going to talk about finding the average value of a function. Now, the mean value for theorem for integrals is one of the big theorems that we learn in AP Calc, and it says that if f is continuous on a closed interval a to b, then there is a real number u between a and b for which the definite integral equals f of u times b minus a. Now, what this suggests is that the area under the graph from a to b, under that blue graph there, is equal to the area of some rectangle of width b minus a. So the width of this rectangle right here is b minus a. And the height of the rectangle, either here or here, is f of u. And that value of u is going to lie between a and b somewhere. Now, there doesn't have to be a unique value of u. The function can reach that height more than one time as illustrated in this picture. But basically, what it is saying is that the function, if you could flatten it out, so to speak, and make it into a rectangle, it would fill up that same amount of area as the area under the curve. So let's look at an example here. I want to find the number u guaranteed by the mean value theorem for integrals for the definite integral from 2 to 6 of x squared. So because the function is continuous, I'm going to make sure the conditions are satisfied. F is continuous because it's a polynomial, it's continuous. On the interval 2 to 6, there has to be a real number u such that the integral from 2 to 6 of x squared dx equals f of u times 6 minus 2. Now, in this case, f of x is equal to x squared, so f of u would just be u squared. So the definite integral, or the antiderivative rather, is 1/3 x cubed. We would plug in 2 and 6. Okay. If you plug in 6, you get 216. So it's 1/3 of 216 minus plugging in 2 would give you 8. And that's got to equal u squared times 4. All right. 1/3 216 minus 8 is 208 over 3. And that's got to equal 4u squared. So if we bring our work over here, all we do is solve for u. So divide by 4 and take the square root. So u would equal the square root of 52 thirds, because we reduced it a little bit, which is approximately equal to 4.163. The important thing is that 4.163, it lies on the interval from 2 to 6. And that's what we're saying. U is guaranteed to be on that interval by the mean value theorem for integrals. Now, if when you solve for u and you get multiple answers, you want to only report the ones that are on the interval that is given on the integral. Okay? Now, the mean value theorem for integrals leads into finding the average value of a function. Because if you remember, the mean value theorem says that the definite integral is equal to f of u times the width. Well, if we divide both sides by the width, essentially that gives us the average value of the function. So again, if the function's continuous on a closed interval, then the average value, y bar, of f over the interval is equal to 1 over b minus a times the definite integral. B minus a is the width of your interval, okay? Of the full interval. So really, it's like you have 1 over width times the definite integral, which essentially represents the area. And if you divide area divided by width, you get average height. Another way to understand that is that the average height that you get is if you compressed that region down into a rectangle of the same width, that's the height that you would get for that rectangle. All right, so let's look at an example to try to like put some teeth into this. So if we want to find the average value of x cubed on the interval 0 to 3, or excuse me, 0 to 2, all right, so y bar is equal to 1 over b minus a, 2 minus 0, times the definite integral from a to b, so from 0 to 2, of x cubed dx. So that's 1/2 times the antiderivative, which is x to the fourth times 1/4, evaluated at 0 and 2. So that would be 1/8 times, if you plug 2 in, you would get 16. Minus plugging in 0 is going to give you 0. So 1/8 times 16 is going to give you, um, it's going to give us 2. Oop, we got 2 there. So graphically speaking, the average height gives us a rectangle of height 2, okay, which is going to be equivalent to the area under the graph from 0 to 2. Okay. Now, another result is that you can actually find the value at which the function reaches its own average value. And that's another result that will happen since the function is continuous. And all you have to do is set x cubed, because that's the y value of the function, equal to its average height, which is 2. And then x in this case would be the cube root of 2. And that would be the coordinate of this point right here, would be cube root of 2, comma 2. Okay? All right, guys, that's it for this video. Hope that was helpful. We got one more for this section.